This video is to find the potential at a point due to a point charge. So to say, we have a point charge plus Q at point O, and due to this point charge plus Q, we want to find, say, the potential at this point P. The point P, as you can see, is at a distance r from a point charge plus Q. So to say, OP is distance r. So let us start with the definition of potential at a point. As you can see written over here, the potential at a point is the work done to bring a unit positive charge from infinity to that point. So to say, if we want to find the potential at point P due to this point charge plus Q, then we have to so to say measure what is the work done to bring a unit positive charge from infinity to this particular point P. So say if this point over here, the small point over here is infinity, say for example, is the point at infinity. And we have a unit positive charge, that is plus 1 charge. We have positive and unit, plus 1 charge. So we have plus 1 charge at infinity here. And the amount of work that we have to do to bring plus 1 charge, unit positive charge from infinity to this particular point P is what is the potential at this particular point. Now, one thing I would like to mention over here, a unit positive charge or any other positive charge will always be repelled by this plus Q charge over here. So this point P is already under the influence, so to say, of plus Q charge over here. This plus Q is already given. So if you have a unit positive charge and you want to bring unit positive charge or any other positive charge from this point over here, from any point towards this point P, so you have to overcome a force of repulsion due to this plus Q charge, because we already know like charges, they repel. So unit positive charge, when we are trying to bring it, it is also all the while being repelled by our plus Q charge. So against the force of repulsion, we have to bring the unit positive charge from infinity to point P. So we of course therefore have to do work to overcome the force of repulsion. So that amount of work that we need to do to bring the unit positive charge from infinity to this point P is what is a measure of potential at this point due to this plus Q charge. Now, instead of a unit positive charge, let us consider a positive charge Q naught. So Q naught means plus Q naught. So we have a charge plus Q naught, or Q naught simply, at point A. Now, this point A is at a distance x from point O. Now, what we will see is, we will see what is the work done to bring plus Q naught from point A to point B by displacing it by a small distance dx. Dx is a very small distance, and we want to see, so this Q naught is also being repelled by plus Q, remember, because both are positive charges, like charges. So see, the force experienced by Q naught at point A due to plus Q, due to this charge at point O, is this much according to Coulomb's law, 1 by 4 pi epsilon naught Q naught by x squared. And this is of course directed towards OA, remember, because Q is being repelled by plus Q, so it is being repelled along OA, or along BA also, you can see. So this is the force of repulsion that Q naught is experiencing at point A. Now, against this force of repulsion, we want to see what is the work done to move Q naught from point A to point B. Now, in order to move Q naught from point A to point B, by displacing it by a small distance dx, we have to do a small amount of work, dw. So, dw is the small amount of work that we have to do to displace Q naught from point A to point B against the force of repulsion, F. So as we know, work done is force dot displacement dx. So work is a dot product, as we already know. So this is F dot dx. Now, as we've already seen, the force F is directed towards OA, that is towards our right hand side. And we are displacing it from A to B, that is towards our left hand side. So to say, the force F and displacement dx are oppositely directed. So F dot dx is equal to F dx cos 180 degrees, since F and dx are oppositely directed. So cos 180 degrees is minus 1. So instead of this, we have minus F dx. So substituting the value of F, So we have dw, the small work that we need to do to displace q naught from point A to point B is minus 1 by 4 pi epsilon naught q naught by x squared dx. So this is the small amount of work that we have to do to displace q naught from point A to point B. Now what we will see is, so the amount of work that we need to do to displace q naught from A to B is dx. This we've already calculated. Now we will see, therefore, what is the work that we need to do to bring q naught from infinity to point P. So the work that we need to do to bring q naught from infinity to point P by this big distance from infinity to point P, to displace it by this big amount of distance, that work has to be a sum of these kind of small dw's. dw is the work that we have to do to bring q naught from A to B. So this is a small amount of work that we have to do. So to bring q naught from infinity to point P, it has to be, we have to displace q naught by a lot of dx's like this. So small dx here, small dx here, small dx here, small dx here, small dx over here. Okay, so by adding up a lot of dx's, by displacing it by a lot of dx's like this, or in other words, by doing a lot of dw amount of works, all right, what we do is we can bring q naught from infinity to point P. So we will now calculate the work done to bring q naught from infinity to point P, and it simply is a sum of these kind of small dw's. Therefore now the work done to bring q naught from infinity to point P is w, which is a sum of these kind of small dw's. So integration of dw's. So simply substituting the value of dw from here now. So which is equal to integration of minus 1 by 4 pi epsilon naught q naught by x squared dx. Now what will be the limits of integration? The limits of integration will be, we are bringing, as you can see in the picture here, we are bringing q naught from infinity to point P. Where is this distance infinity measured from? Our point of reference, or we are measuring the distance from point O. Distance of point P from O is r. Distance of point A from O is x. Distance of this point from point O is infinity, remember. So point O is our point of reference. So we are measuring the distance. So we are bringing, so to say, q naught from infinity up to distance r. Okay, so that is the limit of integration, because we are bringing q naught from infinity to point P, which is distance r apart. Now, since 1 by 4 pi epsilon naught q naught and the minus sign, they are all constants, so they can be taken out of the integral sign. So w is minus q naught by 4 pi epsilon naught. So integration infinity to r, so this is a plus sign. I actually happen to write a minus sign over here, but minus sign is already taken out, so that minus is actually a plus. Okay, so please do not get confused. So you don't have to write this plus sign, of course. So what is only left inside the integral is 1 by x squared dx. Now integration of 1 by x squared is minus 1 upon x, because integration of x to the power n is x to the power n plus 1 divided by n plus 1. So using this formula, please check this yourself. So integration of 1 upon x squared is minus 1 upon x, the limit of integration being infinity to r. Now we only need to substitute the values of the limits of integration. So we can take out this minus sign also outside. So minus into minus becomes plus. So minus into minus is plus. So we have w is q naught by 4 pi epsilon naught. Substituting the upper value, upper limit, so to say, 1 upon r, minus substituting the lower value, 1 upon infinity. So 1 upon infinity being 0. So w becomes equal to 1 by 4 pi epsilon naught q naught by r. So the work done to bring charge q naught from infinity to point P, as you can see, is 1 by 4 pi epsilon naught q naught by r. But we do not want to get what is the work done to bring q naught from infinity to point P. We want to see what is the work done to bring a unit positive charge from infinity from infinity to point P. So if the work done to bring charge Q naught is this much, therefore the work done to bring a unit positive charge from infinity to point P is V, which is W by Q naught. W is the work done to bring charge Q naught. So the work done to bring a unit positive charge is W by Q naught, which is equal to 1 by 4 pi epsilon naught Q by R. And by definition, this, that is the work done to bring a unit positive charge from infinity to point P, is what is your potential at point P due to this charge.